Hello, second grade. Welcome back. Today is Thursday, and I'm excited about teaching math today. We're going to do a couple of different things today. I'm going to start sharing my screen with you. And the first thing that we're going to do is we're going to do some quick images. And we did these last week. What we're going to do here in just a second is I'm going to click on this little stopwatch, and you're going to see some coins. And what I want you thinking about while the coins are up there, I want you thinking of two things. First, what coins do you see? And second, I want you thinking about the total number of coins. So we're not worried right now about how much money is on the screen. We want to know how many coins are on the screen, and we're going to see if we can describe those using equations. So you're going to see this for just a second pop up, and then it's going to go away. Here we go. Okay, so think about what you saw. I'm going to show it to you again in just a second for you to get a better idea of what you see. Remember, what coins do you see and how many coins? Okay, here we go. All right, so in your head, you should have a picture of what just popped up on the screen, and I'm going to pull it up for good. So let's talk about what we see. How many different coins do you see? Not how many coins, how many different coins? Good, 3 different coins. Which one of these coins is a nickel? A nickel. Good, these two right here. This is the back of your nickel. This is the front of your nickel. Which one of these is a penny? Good. Pointing here, 1 penny. Which of these is a quarter? Ooh, did I trick you? There's not any quarters up there. What are these 3 called right here? Yes, these 3 are called dimes. So we have penny, nickel, dimes. So let's talk about the total number of coins. How could we write an equation that shows us the total? Okay, good. I'm picturing that a lot of you are going to say 1 penny plus 2 nickels plus 3 dimes equals how much? Well, 1, 2, 3, 4, 5, absolutely, 6. But I wonder, is there another way you could have thought about this? Absolutely, 2 nickels plus 1 penny plus 3 dimes. What does that equal? 1, 2, 3, 4, 5. Oh, it's still 6. Is there another way you could have thought about this? Absolutely. Maybe you pictured the dimes first. 3 dimes plus 2 nickels plus 1 penny. What's that going to equal? Yes, it is still going to equal 6. There are a lot of ways that you could have thought about this, and these are called number strings. And we're going to be doing a lot of work with number strings today. But we're going to do one more quick image before we go on. Okay, let's do another one the same way. Here you go. That was a lot of coins, so be thinking in your head about what you saw there. Okay, there it is again. And here it is for good. So first, let's talk about the coins that we see on the screen. What are these 3 right here in the middle? Do you remember? Good. Those are our dimes. Those are our dimes. What about these 4 here? Yes, those are our quarters. Those are the ones we didn't have last time. What about these 2? Absolutely, nickel. What coin do we have that's missing up here? Right, penny. We have no pennies up here. So now let's talk about how we may have found the total number of coins. Who saw the dimes first? Okay, some of us did. Who saw the quarters first? Good. Who saw the nickels first? Absolutely. When I first saw this, I think the quarters jumped out at me first, probably because they're the largest. How many quarters do I have right there? Good, I have 4. Let's just go backwards. How many dimes? Good, 3. And how many nickels do I have? 2 nickels. So 4 plus 3 plus 2, what does that equal? Well, let's practice counting on. There's 4, 5, 6, 7, 8, 9. 9 coins. Could we have thought about it a different way? Absolutely. So maybe some of you saw the dimes first. 3 dimes plus 2 nickels plus 4 quarters. Let's see what that equals. Let's count on again. 3, 4, 5, 6, 7, 8, 9. Did anyone see the nickels first and just go in order from there? You probably did. 2 nickels plus 3 dimes plus 4 quarters equals, yes, still 9. Very good. Like I said, these are called number strings, and we're going to be talking about some different number strings today. So what you're going to see is a little story problem with some cubes. And I'm going to read the story problem, and I want you picturing in your head what's happening here. Jake is building with cubes. He has a tower of 2 green cubes, a tower of 5 blue cubes, and a tower of 3 yellow cubes. How many connecting cubes does he have? So think about that again. Jake is building with cubes. So picture what he has. He has 2 green. He has a tower of 5 blue cubes and a tower of 3 yellow cubes. How many connecting cubes does he have? So how could we figure that out? Absolutely. We could add our 2 green plus, how many blue there do you see in the middle? 1, 2, 3, 4, yep, 5 blue. And I'm kind of color coding this because I want you to see where these numbers came from. Plus 3 yellow. Ooh, that yellow is bright, isn't it? And that equals how much? We could practice counting on 2, 3, 4, 5, 6, 7, 8, 9, 10. What if we kept the cubes the same, but we changed the order? So let's look at the equation that we have now. We still have 2 green, but this time we don't have the 5 blue. What do we have in the middle here? Yeah, the 3 yellow. Absolutely. Plus, what's last here? Yeah, the 5 blue. Let's see if when we change the order here, if we get the same answer. So this time I have 2. Let's count on 2, 3, 4, 5. Make sure you're counting with me. 6, 7, 8, 9, 10. I still have 10 over there. Let's switch it up a different way. Let's put the 2 greens in the middle this time. Okay, I want you to think about your equation here now. We started this time with 3 yellow plus, what's next? Right, 2 greens. We're changing up our order, but our numbers are staying the same. Plus 2 plus our 5. What would that equal? Let's count on 3, 4, 5, 6, 7, 8, 9, 10. Why do you think that 2 plus 5 plus 3 equals 10, 2 plus 3 plus 5 equals 10, and 3 plus 2 plus 5 equals 10? Why would all of those equal 10, but the numbers are in different orders? Absolutely. the numbers of the cubes didn't change. We just moved around the numbers. So I wonder if that's something that could work all the time. So number strings that we're going to be working on today are very similar to these problems that have multiple add-ins, which means I'm adding more than two numbers. Multiple means several. So I'm going to move this over to the side. And we're going to kind of ignore these cubes for a second. I'm going to put a type of problem up here that you may see. These are called our number strings. So I want you to think about how you would solve this problem if you saw this. 8 plus 5 plus 2 plus 8 equals blank. How would you solve that problem? Now I want you thinking about our addition strategies. How might you solve 8 plus 5 plus 2 plus 8? Okay, you may start with 8 plus 2. Why do you think that someone would start with 8 plus 2? Because they're not next to each other in that order in this equation. Right, because we know that 8 plus 2 equals 10. It's a nice, friendly number. So we could start by solving 8 plus 2 if we wanted to solve this number string. So if we started with 8 plus 2, what do you think would be the next step? We've used this 8 and we've used this 2. What would we need to add next, do you think? Yeah, the 5 and the other 8. Anyone know what that equals? That's a tough one. Good, 13. Now I have one more step. If 8 plus 2 equals 10 and 5 plus 8 equals 13, I've got to add my 10 and my 13 together. 10 plus 13. Anyone know what that equals? That's a tough one. Absolutely, 23. If you're having trouble here, you can use your number line, you can use your 100 chart to help you out. I want to show you one more way to solve this problem, and then I'm going to let you work on some number string problems. Another thing that I see in this problem that might be helpful are doubles. Does anybody see doubles in here? Two numbers that are the same? Absolutely, 8 plus 8. So some of us might start by solving 8 plus 8. What does that equal? Good, 16. Now I'm left with a 5 and a 2. So let's add 16 plus 5. Anyone know what that equals? That's a tough one. 21, good. And then 21 plus 2 equals 21, 22, 23. So you are going to be working on a lot of these number string pages. So let me show you these real quick. All right, you're going to work on looking for combinations of 10. This is one of the pages that you're going to look for. This is actually the last page that you're going to be doing today. Let me see if I can find some of the number string pages. They may not be on here, and that's okay if they're not. Problems about 3 groups. This is what you're going to work on first. So there are some cubes, and you're going to have to answer the problem that's put up there. How many cubes did he use? And then these number string pages. There are a lot of these number string pages. What you're going to do is use combinations you know to solve each problem, show your work. So if you just put an answer on these pages, that's not going to count. You've got to show me how you figured these out. And there are a lot of these pages. You're going to have time to work on these tomorrow as well. So don't worry if you can't get to all the pages. You're going to have a lot of time to work on them tomorrow as well. I would suggest getting about half done if you can. See you all later.